Hi dears, I am Mathan, Assistant Professor, Department of Mechanical Engineering in BSN College of Engineering and Technology in Tirunelveli. So now we discuss and explain about the Rankine cycle. So this is the content of Rankine cycle: definitions, principle, construction, working, energy analysis, then ideal Rankine cycle, etc. First, the Rankine cycle is a modification of Carnot cycle. First, what is mean? Rankine cycle. So the Rankine is the ideal thermodynamics cycles involves a constant pressure heat engine which convert into mechanical work. This is a Rankine cycle. So Rankine cycle is a modification of Carnot cycle. The Carnot cycle is a reversible closed thermodynamic cycle. So just use small of modifications with this Carnot cycle. When the Carnot cycle has been used, it had some mistake. So Mr. Rankine give the solutions and give the update cycle. So the cycle is called as Rankine cycle. What's the main objective of this Rankine cycle? To understand the principle of thermodynamics, and is also able to use for bulk behaviors of some simple physical system. This is the main objective of this Rankine cycle. So first, what is the principle of Rankine cycle? So the work on principle of heat engines which converted chemical energy or fuel in thermal energy for these generations of steam. This is the principle of Rankine cycle. So this is the main component of Rankine cycle. First one is a steam boiler, second one is a steam condenser, third is a steam turbine, fourth one is a feed pump. So this component, you know that so many boilers there. So first one is a boiler, right? The boiler is closed vessel in which fluid is heated. This is the main use of boiler. So there are different type of boiler is there. Different type of materials is there. So some stainless steel, alloy steel, and cast iron. So many materials is available in market in steam boiler. So depending on the applications, when you change of materials. So the next one is a steam condenser. So condenser means it is a heat exchanger, that is heat transfer. It is a heat transfer used to convert a gaseous substance into a liquid state and transfers cooling. That is means simply saying that it's a gas to form, the gas is converted to the liquid. So this condenser is connected to the pump. So condenser is a cooling device. It's a heat exchanger. Condenser is a heat exchanger. Then third one is a steam turbine. So steam turbine. So turbine means it is a mechanical device. That is, the turbine is a mechanical device, and the exchange energy from a feed flow and is converted into useful work. This is called as turbine. So many turbine is there in market and in application, development application. So steam turbine and the gas turbine, transport turbine, and water turbine, that is like Belton, Francis, Kaplan turbine. So many type of turbine is there. And fourth one is a fluid pump. So pump, it is electric energy is converted to the pressure energy, that is, and the electrical energy is a pressure, that is mean hydraulic energy. So pump is a device, that is so many type of pump is there. So main type is a positive displacement, that is like gear pump, piston pump, screw pump, etc. This is a positive displacement. The second one is a centrifugal pump. That one is a ACL pump. So many pump is available in market. So this is the four common we are using for the Rankine cycle. Is a boiler, condenser, steam turbine, and feed pump. This four component is connected to the Rankine cycle. So it's a simple ideal Rankine cycle. This is a simple diagram. Here is a diagram of temperature is a entropy. What is a temperature? Temperature, you know that. So and entropy, you know that. Entropy is a measure of system's thermal energy per unit temperature that is unavailable for doing useful work. This is a entropy. Temperature is a hardness, a degree of hardness, you know that. And here is a T and S diagram for Rankine cycle. So four components there. First the pump, boiler, turbine, condenser. The pump is process 1 to 2. Boiler is 2 to 3 process. And the turbine is a 2 to 4 process. And condenser is a 4 to 1 process. But here there are four cycles. So 1 to 2 processes and it's isentropic compression. This is 1 to 2. That is pump. Pump is working on electrical energy is converted to the hydraulic energy. It is a process of isentropic compression. And second is a boiler. Boiler is boiler is a closed vessel in which fluid is heated. That is a process 2 to 3. That is isobaric heat adding. That is heat adding process. And the third one is a turbine. Turbine is a device. This is energy, extract energy from fluid flow, is converted to useful work. This is a process 2 to 4. That is isentropic expansions. And fourth one is a condenser. Condenser is a cooling device. The gases to liquid. It is a 4 to 1 process. It is a isobaric heat rejection process. So this is a is a process of Rankine cycle. So first one, this process is started from the fluid pump. The fluid pump is to pump of the fluids, that is water. The pump is used to electric energy to the hydraulic energy. The feed pump supply to water is necessary support to this steam boiler. In device, heat is supplied for the generations of steam from supplied water. When the steam is generated, it is transferred to the steam turbine and the turbine start to rotate and give the work done. So after this steam is transferred to the steam condenser, where the heat is rejected and steam is converted into hot water. So this hot water is converted to cool water, which is supplied to the pump. So after cycle is a repeat again. So first process is a H means, what is H means enthalpy. So what is mean enthalpy? That is enthalpy is a sum of thermodynamics, the internal energy, that is mean product of the pressure and volume. This is a enthalpy. So internal energy, so H1. First process 1 to 2, that is a isotropic expansion process. This process is a low pressure to high pressure. So low pressure is converted to the high pressures. So this pressure is go to the boiler. So using paint pump. So the heat is added to the boiler. So the process 2 to 3, there is a isobaric expansions. It's a heat adding process. It's a boiler. So boiler is used to the heating the waters around development of applications. First H3 minus H2 is a heat adding in boiler. That is in case this when you add in heat, the rate of heat transfer is increased. That is Q. Mass flow rate is increased. So in case all temperature, pressure, entropy, that is almost increased for the boiling condition 2 to 3 isentropic expansion. After complete the isentropic expansions, is go to the turbine. The turbine is already discussed. The turbine is it's a device, mechanical device is converted to the useful work, mechanical work. So this work is a 3 to 4. So turbines work. This when you working of turbine is to increase power. That is, power means work into mass flow rate. So automatically the power will be produced in the turbine process. So after complete the turbine, the useful work is out to the condenser. The condenser is a cooling device, a heat exchanger device. So hot vaporized steam is converted to the cool off waters. So steam is converted to the water by using for condenser, it's a heat exchanger process. So after this completed for this cycle, the cycle is a repeater. So this is the cycling of Rankine cycle. So here the net weight work of turbine minus water work. So heat supply is inlet heat minus inlet out, that is heat adding and heat reject. The thermal efficiency is a formula is work done by heat supplied. So work done is already found, work done, and Q in means heat adding. This is a thermal efficiency calculation formula. So already we discussed ideal Rankine. So first cycle process 1 to 2 isentropic pump, that is mean isentropic expansion. Second one is 2 to 3, that is constant pressure heat adding, that is constant pressure. So pressure is maintained but the temperature is increased for the heat adding process. So for that one is 3 to 4, it's isentropic turbine, that is means isentropic expansions. It's the same. Pressure is a decrease. Pressure is a decrease, temperature is a small decrease, and isentropic is a decrease. So all conditions is a decrease from the isentropic turbine, from the boilers to the isentropic turbine. And last 4 to 1 is a constant pressure heat rejection. That is mean the pressure is a constant but temperature is a decrease. It is a condenser process. So after force process to complete to the Rankine cycle. Here I briefly explained the Rankine cycle. Here this is a pump, this is a boiler, this is a high pressure turbine, this is a low pressure turbine. First the water is transferred to pump. The pump in the electrical is converted to the hydraulic energy. So low pressure is converted to the high pressure. The pressure is increased. For example, the pump pressure is, the water pressure is 1 bar. So the pump is pushed off the water in boiler is around something 2 or 3 bar. So pressure is increased. So boiler. So here 1 to 2 is a isentropic expansions. So the temperature is increased. The temperature is increased. The pressure is also constant. So pressure is a increase. So 1 to 2. So the boiler is a heating of water. So is a boiler. Boiler is water is a heater. So water is temperature will be increased. So 2 to 3 is a heat adding process. So this heat adding process means the temperature almost increase. So that is increase. That is temperature is increased. Same time entropy is also increased. So that is same. Entropy is a increase, but temperature is a constant. Temperature is a because the boiling temperature of water is a those 100 degrees Celsius. When you reach the 100 degrees Celsius, the water is converted to the steam. Already you know that the water is 100 degree you reach, the water is converted to the steam. That is a constant will be the temperature of water is steam is constant and entropy is increased. So entropy almost increased. So after to complete the boiler, the water steam is going to the high pressure turbine. So the high pressure turbine, the turbine will be rotate to give the mechanical energy. This mechanical energy is converted to the electrical energy. So by using the generator. Okay, then here this process 2 to 4 is a high pressure. So the high pressure of steam, high pressure temperature, entropy. So high entropies. So all those is increase. This value is increase. So this all values go to the high pressure turbine. So after the high pressure turbine is completed, then so this is high pressure. So that is pressure temperature will be reduced. The entropy is a constant. This is a high pressure turbine. This is a temperature is a decrease. Entropy is a constant. So after complete this process, then go to the boiler. The water is going, steam is going to the water boiler. So boilers again, they maintain the temperature, but they maintain the pressure, constant pressure, but temperature it is increase. Again it's increase. So temperature is increase, pressure is constant. That is a boiler conditions. So when release of water, release of steam. So these conditions, constant pressure but temperature increase. So this is a 4 to 5. 4 to 5 means the temperature almost increase, entropy increase, and pressure is constant. Pressure is constant. After reaching the cycle 5, process 5, this process go to the low pressure turbine. So these conditions, after release the low pressure turbine of water, it is a totally the temperature decline. That is temperature totally decrease at constant entropy process. So after to complete low pressure turbine to reach the steam to the condenser. The condenser is a heat exchanger device. So gas is converted to the water. So the water is again go to the pump. That is cycle is again process continue for 1 to 2, 2 to 3, 2 to 5, 5 to 4 to 5, 5 to 6, 6 to 1. So cycle is a repeater. So this is a Rankine cycle and a reheater. So this is the combined same. It's a repeat process. That is 1 to 2, 2 to 3, 2, 3, 4, 5, 6, 7, 8. The repeat process. Here combined cycle. So it's an interesting topic. It's a combined Rankine cycle. There are two cycles there: vapor cycle, another is a steam cycle. Vapor means we are using for the air, and steam cycles we are using for the water. So first to work on the air. working device. So first the air go to the boiler. Boiler is a heating. Okay, so the heat of the water, the heat of the air. So air is a heater. This heat air is go to the turbine. Turbine is the rotate of the mechanical device to connect to the generator will produce of electrical energy. So to release of the air from turbine to heat exchanger to release of heat. So this is a air cycle, vapor cycle. So this is a steam. Steam means we are using for the water. So the water we are going to the that is a heat exchanger. It's not using for boiler, heat exchanger. So what is a heat exchanger? This air is released from heat to the water. So water will be heat by using release of air heater. So that is the water is a heater. So when you reach on the 100 degrees Celsius of water to form of steam. So the high pressure and high temperature, high entropy of steam is coming from to the turbine. So turbine is a rotating device to connect to the generators and to produce electricity. So turbine to release the low pressure and low temperature and low isentropic. This is go to the condenser. The condenser into all vapor to liquid. So low pressure. The low pressure connect to the pump. Pump is the increase of pressure and the process is repeated. This is a vapor cycle. This is a steam cycle. So only change of heat exchanger. Yes, the water is heated by the release of air heat. So this is a small change of combined cycle. So for an example, some example. For example, the pump, the feed pump. So the feed pump is the water to pump to the water. So some example, in case 15 megapascal to pump the water to the boiler. So boiler is a heater of water. So water will produce of steam. So here the pressure is same after release of boiler, but temperature is increase. So pressure is constant, temperature is increase. So this is a boiler conditions. Pressure constant because the inlet pressure is 15 megapascal. The output pressure is 15 megapascal. So pressure is constant, but temperature is increase. So this pressure and temperature of steam is go to the high pressure turbine. So high pressure turbine. So the turbine is rotate. So high pressure of turbine is rotate to the shaft. So after release from high pressure turbine of steam, the pressure is a decrease. Look that. So inlet temperature is 15 megapascal, but outlet temperature is 1 megapascal. So same time the temperature also decrease. The temperature is a decrease. Pressure but decrease. Temperature is again to heating the steam by using boiler. So this steam is going to the low pressure turbine. That is the pressure is 1 bar. So bar pressure there is no change. This is a boiler. So finally concluded the boiler to maintain the constant pressure. That is constant pressure, but temperature is increased. This is a conclusion of boiler. So pressure is same, temperature is increased. So these conditions to go to the low pressure turbine. Low pressure turbine. So the shaft will be rotate. The shaft is connected to the generator. Generator is the producer of electricity. So here the pressure totally is down. Here is a 1 bar, 1 megapascal, but is a 10 kilopascal. The temperature in the pressure is totally down. So the pressure is down, at the same time temperature is down, decrease. This condition is going to the condenser. Condenser is a heat exchanger. So hot steam is converted to the water. So this is a cooling water to cool the steam. So the steam is converted to the liquid. So liquid is the pressure. So there is no effect of pressure. So it is a 10 kilopascal and it is a 10 kilopascal. So there is no effect of pressure. But the temperature totally down. That is mean decrease. So less than 50 megapascal. So next is the boost of pressure by using the pump. The pressure is down from condenser. The pump to the increase of pressure, that is 10 megapascal to convert to the 15 megapascal of pressure of water. So again the process will be repeated. So this is a Rankine cycle. So expansion, that is a expansion, heat adding, and then it is a isobaric expansion turbine process, and finally the heat rejection process. Finally the process is complete. So it is a small calculations, like in case and the pressure released from the condenser, the 15 megapascal, and the temperature 46 degrees Celsius. We say assume. I mean we have simple calculations. Right? It's a simple calculations. Boiler. Okay, boiler already we discussed is a heating of, is a heat adding process. So here temperature is 600 degrees Celsius, but inlet temperature 46 degrees Celsius. So temperature is a increase. Then pressure is 50 megapascal. So pressure is 50 megapascal. So there is a no effect of pressure. So pressure is a constant. Next, it is a enthalpy. Enthalpy 15,3583 kilojoule per kilogram. That is our enthalpy. So this input values is going to the high pressure turbine. So high pressure turbine to release the values pressure. So pressure is a decrease and temperature is a decrease. Already we discussed the pressure decrease and temperature decrease to the from the turbine process. So next entropy. Okay, here the entropy, there is no change. So what is the entropy of S1, S2 is a constant value. So there is no effect of entropy but effect of pressure and temperature. This is a turbine. So this high turbine is going to the, this value is going to the, again is a boiler. Boiler is heated. So already it is a boiler is a constant pressure but temperature is increased. So here is a temperature decrease but pressure is decreased. The pressure is, there is no change after release from boiler. So here 1 bar. But temperature 197 degrees Celsius. So temperature is pushed. Yes, 600 degrees Celsius the temperature increase. But the enthalpy is also increase and process H2 is a decrease. H1 is a value 3000 and H2 is a decrease after dumping. But enthalpy is increase after boiler. So this is small values. So this is a calculation. So totally heat input is 4254 kilojoule per kilogram. This is a simple calculation of Rankine cycle. So the ideas, please note that the boiler is a constant pressure. Turbine to reduce the pressure and temperature, but there is no change of entropy. That is, entropy is a constant. Here is a pressure constant. In turbine is a entropy constant, and condenser. That is for the condenser means here condenser means pressure is decrease, temperature decrease, entropy all is a decrease. So this is a condenser. Here is that is formula. Efficiency of thermal efficiency is the turbine output plus turbine work, pump work and heat input. So finally this all the values substitute in here. So totally 45 percentage of thermal efficiencies for this Rankine cycle. So this output of heat is, that is heat reject of means 2344 kilojoule per kilogram. So this is a heat reject, and finally the efficiency 45 degrees Celsius thermal efficiency.